Hey folks, good morning. Okay, we are going to go through a ritual right now. One is going to be, can you hear me? And the other is going to be, can you see my screen? Because if you can do both, then we can start with the live session today. Rishi Natakam, good morning. I am very happy to see that you are from, I think you're joining from the UK and EU. Is that correct? So I replied, I'm currently in India. Uh, if anyone can hear me, please let me know. Yes, a yes will help. And also, if you're able to see the screen over here. Is there a lot of lag? Is that the reason why I'm not seeing any messages on chat? So I can't say for sure. Okay, Rishi, awesome. Good morning, Arjun. Good morning. Good morning, everyone. And welcome to this uh, live session number 6 on AI engineering. The purpose of this series is to help you transition from software engineering to AI engineering, and this will be the final lecture in this series. It's going to be a conclusion, but at the same time, we will be moving to this website Interview Ready, which is my website for future live classes. Okay, and the reason I'm doing this is because A, it's more interactive, and B, I mean, I can't keep this space up forever, so better to move to a more streamlined place where I can have questions taken on Slido, and I can have all this stuff set up and then link it back to the lessons in the course. So yes, in short, future live classes will be at Interview Ready, but this is going to be a fun session. It's going to be around building an end-to-end application on AI application on a very common use case. So if you're a software engineer who's looking to transition to AI, you will find this session today useful. Yes, Arjun, I'm very happy to see that I could figure out the 1080p resolution, how to do that. So good stuff. Okay, so for the next 2 minutes, we will be taking questions. Any questions that you have around the topic today are welcome, and I'll try to answer them quickly. So please let me know till 9:05. We'll be taking these questions. It'll also give me a sense of how much lag is there. If I'm saying 9:05 at 9:03, then and you're going to get this audio later, then you know how much lag is there between here and there. Also, there's a very useful resource on GitHub. These are some extremely useful research papers that I have discovered. Um, I mean, they're also on Hugging Face if you search enough, but no, not all of them are on Hugging Face. Basically, some of these are years old. So this has been a result of a lot of breadth first and depth first search from my side. I have taken them down topic by topic, but in reality, when I started going through the papers, I started with vectorization first, um, like this. One second. There's a particular paper which I would, yeah, this is where I started. Billion scale similarity search, Milvus DB, TensorFlow, Ray. These are the things which actually helped me transition from a software engineer to the AI engineering mindset. Okay, so I'll just share the GitHub resources link, and you can keep these papers. Maybe you can bookmark it or star it because it does help. Quite a few people have already started. Yes. Okay. Wonderful. If you ask me where is the future of these models, I think it's over here. It's image transformers and video transformers. And if you ask me what's the future of LLMs, large language models, then I think it's Where's JEPA? Oh, there's no JEPA. I haven't mentioned it. Interesting. But there is something called iJEPA and vJEPA. Let me see if that's here. No. Yeah, this is the one. I think this is the one. Video jam. No, this is not the JEPA paper, but it's similar. Yeah, joint embedding abstractions with self-supervised video masks. This is exactly what I was talking about. Yeah. So this is pretty interesting. Maybe you can have a look. I'll just share it in the chat. Okay, folks, let's start. Let's head to our main agenda for this talk, which is explaining how applications can be developed using AI. And I'll take a real world example. I'll basically take the example where on my website, when a person asks a question related to a video lesson, let's say. So this is an educational website. A customer or a student or an engineer asks a question. The question has to be responded to, right? So usually this is what used to happen before LLMs. There would be a human who would actually get a notification, and after getting a notification they would go and open their dashboard. Here they would see the question, this question, and then they would respond to it. The response would then result in a notification to the student, who would then either log into the website, or they would maybe they were already logged in, but they would need to visit the website again. Okay, visit that particular page. This might seem like just a couple of steps, but it's not. Each and every one of these steps is a place where a customer can drop off. Okay, firstly, asking a question, this is the bare minimum that they need to do. Sending a notification to the admin, this person whose name used to be usually Gaurav Sen. He would respond to it. First, he would view it on the dashboard. This could cause a delay. He might be outside. Then he would respond to it, which means he would need to think about it and then give a response. Here also you might see some delay. Then you would get a notification. This is instant. But after notification, would you like to visit the website at your own pace, at your own time? So to improve the customer experience, like to make it perfect, you want to convert these 6 steps into just 2 steps. One is ask a question and get an immediate response. Okay, if you have a large language model, then you can do this. When you ask it a question, you get an immediate response. Why don't I do this for my website? Okay, it's a pretty simple use case. But do you see any problems with a plain vanilla ChatGPT response to any question on the website? Is the use case clear? I think let's first get that out of the way. If you're given this problem statement, you're working for a website where users have queries and those queries are manually being answered by another person. How do you make this a super fast flow? By probably bringing in a large language model in between. But if you bring in the large language model, what could be the problems? Let's note them down one by one. I write down the first one, which could be cost could be a factor. Maybe this model is expensive. I'll put a question mark so that you can think about this. Number 2, what could be the second problem, guys? One thing which is really, really big is the quality of the response. Okay, so if a person comes to you and asks you a question and you respond to it quickly but very poorly, then it's almost as good as they didn't get a response, or maybe even worse. Sometimes if you give people the wrong response, it's worse than not giving a response at all. Okay, so I can see answers here. This MRAM is saying that it may not have the context or boundary set up. Okay, boundary here I think is going to be um, relevant and meaningful. So for example, someone asks me that I want to switch careers. How do I do this? Now the question is on a educational website which is for software engineers. Then I should have the context that, oh, I'm a software engineering advisor. Switching careers is limited to software engineering only, in my case. But if the same question is asked to a bot which is an expert in switching managerial roles, or switching from law to math, right? It's going to have a very different answer. So the thought process is dependent on the context, and if you give it the right context, then it will come up with relevant and meaningful responses. Okay. Let's focus on the second part, quality. A lot of us are saying that quality of the response needs to be high. What is quality for us? It needs to be accurate. We can't give people wrong information. It's an educational website after all. Another one that Rishabh has come up with is it shouldn't be generic. So generic, it shouldn't be generic, so you're talking about specific answers. And something that GoPro is mentioning, but what you're looking for is fast answers. Okay, not too long. It doesn't take 3 minutes to come up with a response. It gives you a response in a matter of seconds. It is very specific to the question that has been asked because it's a doubt, and it is accurate. It doesn't hallucinate. It doesn't get things wrong. It is relevant, meaningful. You have set the boundary, set the context, and it is cheap. It's actually extremely cheap as compared to a human being doing this. Okay, and another point is it is really scalable. Gaurav is going to get tired after some time. He will get exhausted. He's going to say, okay, let me take the rest of the queries tomorrow. But a large language model is never going to do that, right? A large language model doesn't sleep. A large language model doesn't make mistakes, does not misread a question, does not try to find intent in the question. It can find intent, it can find tone, but it can still be professional all the time. Gaurav might get tired, Gaurav might have some issues, okay, which start reflecting. So this is the reason why we would like to go for a large language model, and these are some of the considerations that we have. Okay, let's take them step by step. And why are we doing this? Because we are looking to actually deploy an AI application to production. Before this happens, you do some sort of white paper drawings or whiteboard discussion. Okay, so that's what we are doing right now. Eventually, we'll get to the even more practical side of this, that how do you deploy this to prod. Okay, so first thing is cost. Guys, what can we do around cost? If large language models are expensive, or they are cheap, is cost a factor at all? I would say cost is a factor, but not a very big factor. Quality is a much bigger factor. Okay, it's also partly why OpenAI is doing so well, because they do care about cost, but they make it very clear that we'll give you the best quality LLM. And the cost differential is not sufficient for people to switch to different LLMs. I'm talking about small scale, right? If you are a startup or a medium-sized organization, you're looking for the highest possible quality, because in any case you don't get that many doubts, and you don't want to fine-tune the LLM too much. Instead, you do this, which is trade-off cost for quality. So you go for a model which is quite popular. OpenAI is expensive but popular. DeepSeek is another possibility, and so on. I'll take out cost from the equation because it's really not that big a deal at small scale. Quality is something which is pretty big. Scalable is something that the model almost brings to you by itself. Okay, if you're a large organization or a very large medium organization, then you're looking at scalability and cost. Can you tell me one thing that you can do to bring down to make the LM more scalable and also make it cost effective? What is just one technique? Okay, actually there are two. So give me any one and we'll populate them one by one. Rishabh is asking, won't the answer depend on the quality of the question asked? For a vague input, the result will be vague. Yes, these LLMs can predict what you're trying to say given sufficient context, given sufficient background. But you're right, just like if a person asks me a vague question, I will find it difficult to answer. LLM is also going to find it difficult to answer. GoPro is saying increase the context window while trying to make the solution use less tokens. Okay, that's a very interesting approach. So reduce token usage. Okay, so if we can give the model the right context while keeping the number of tokens low, then we will be charged for fewer tokens and life will be good. Okay, so I think what GoPro is going for is information density should be high per token. Don't just give it information that it's not going to use, only send it the information that is relevant to the query. Okay, very nice. So we are going for high information density. Two other things which make a model scalable and cost effective. These are like really popular now, especially with mobile devices. People are trying to make large language models. I mean, not exactly large language models, but they're trying to make these models work for mobiles also. So if you're on an airplane and you don't have the internet connection, it could still work. That's the idea, and this is where a lot of the research is heading towards. Localize it. Okay, Abhinav is saying you can localize it. So edge node, Karthik, that both of you have very interesting responses because you're very close. So you basically want to um, bring the model close to the user, right? Now, how do you do this? Okay, Ninad is saying that basically optimize the model. So have it use less CPU and memory. Okay. How do you do this stuff, guys? Introducing memory. The model does have some memory. If you're talking about caching, then semantic caching can be used. But we are talking about reducing the cost and making the model more scalable. Fundamentally, what do you want to do? if you are being charged for information token usage, what would be one thing that would be useful? What if you can have lossy information? Okay, onboard LM. Nah, Sai, that's a very good uh, try, but it would be onboard SLM. A small language model with fewer parameters, let's say 100 million instead of 100 billion, would be much easier to not just scale, but it would be fast and it would also be cheap because there are fewer parameters that you need to go through during inference time. Okay. So the second point, guys, is first point is information density per token should be high. So for this, maybe you want to make sure that you send the right kind of information. We'll get to this also in a minute. Second point is you want something which is small, something which fits in memory, something which responds too quickly, does not require as much power, does not require as much training time either. And number one, which I think all of us missed, is quantization. These models are neural networks, and those neural networks have weights. The weights themselves are integers or float values. So you have 64 bits or 32 bits for every single weight value. Okay, that's the number of bits that each piece of information takes. But instead, if you condense this into 4 bits or 8 bits, then you will have reduced the amount of space that you need for that model. And so quantization basically takes existing weights in a model, takes a model with large weights and squashes it. Okay, tries to condense that information into 4 bits or 8 bits. It's basically a compression algorithm. Okay, so these are the 3 major ideas that we can use to make our model scalable and cost effective. Okay, if you want to understand these in more detail, I have them covered at Interview Ready. There is, so it's before Transformers Deep Dive, it's here. What are vectors? What is a large language model? Text generation, we discussed this in detail. Even vectors, indexing techniques, and compression and quantization. Okay, so this is relevant. I would recommend this on chat, and this is relevant. LM internals, KB caching, core optimizations. No, not here either. Trade-offs in LMs, yes. Quantization, yes. SLM, distillation, quantization, all this stuff is useful when you're thinking of deploying applications to production. So you can refer those videos. Okay, we have discussed this in slight detail, but what about the 2 other parts in between, quality and boundary? Okay, remember the original problem. The original problem is that we have a educational website, or we have any kind of a website. This might be an e-commerce website. It could be actually a social media website also. And people come up with queries, come up with questions. They have some sort of a reaction to something. You want that reaction to be responded to. For that, you had humans earlier. Maybe I'm not able to log into my account, or I want to change my password, or my phone number has changed. Please help me out. Instead of having a human respond to it, you're just making a large language model respond to it. We have looked at how we can reduce the cost of these models and how to make them scalable. But let's now focus on the most important part, which is quality. The quality of the response has to be really, really good for the humans over here to feel good about your website. If they don't feel good, they're going to drop off and never come back. So that is customer loss. That is much, much more expensive than the model training cost or anything that you will have. Okay, so you can't lose your customers because your business ends then. So To avoid that, you need to keep the quality of responses human-like or very, very good, maybe better than human in some cases. But yes, that's the idea. How do we tackle this? This is the core problem. As an engineer, this is where your expertise will have to come forward. Okay. You can make it scalable and cost effective. In terms of boundary, these are basically validations that you can add here. That no swear words, no jokes, stuff like that. But let's get to the core part, which is how do we make it accurate and specific? How do we improve on those two qualities? If you've gone through the lecture series here, then you should be able to respond to definitely accurate. Okay, specific we'll get to in a minute. Use prompt engineering techniques like chain of thought, zero-shot prompting, role-based prompting. Okay, that is really, really good, Ninad. You have hit specific on the head, okay, in a particular format. You have explained how to reason, okay, example paths. So if someone comes to me and says that, how can I cook something? Let's say, how can I cook an egg? And I tell them, first you take a pan, then you put some oil, then you heat it for a while, and then you put the egg on it. That's one process. Tomorrow if they say, how do I cook some vegetables, I'll say something very similar. You take a pan, put some oil, heat it for a while, cut the vegetable. Something that we have answered, but accurate. How do you make models accurate? Something that we have answered, but accurate. How do you make models accurate? Yes, Imran has come up with the answer. Retrieval augmented generation. I have to double check the spelling of retrieval, but the basic idea is generation is what the model is doing for you, GPT, or some other model. It could be Gamma, it could be anything. It is augmented by some sort of retrieved information. Yep, Varun is saying the same thing. You go for RAG. Let's focus on this part, retrieval. What exactly are we retrieving here? We'll wait for 2 minutes, guys. I'll be waiting for your responses. What are we trying to retrieve? For those of you who are joining just now, some context. Our mission today is to build a customer support bot for a website which will take queries, and instead of having humans respond to all the queries, it's trying to take away some of the load from the humans and put them onto an LLM. So the LLM is now responding to customer queries. We have taken the example of Interview Ready because we have actually done it at Interview Ready. If I go here in quantization and if I ask a question, good morning, how are you? Then the model will not respond to it, okay, because it does not respond to irrelevant queries. Okay, that's basically the validation part of things. Let's see if it does respond to it, then I'll have an egg on my face. No, it didn't respond to it. Okay, so that's good. Now let's try another query, which is going to be what is want to respond to this. But with me sending this query, to. Okay, there is some sort of lag here, or yeah, I think it's because I'm streaming at the same time. It's really slow. What is quantization in a small language model? Let's see what it responds with. Yeah, quantization in a small language model refers to the process of reducing the precision of numerical representation of blah 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 blah. Blah. Oh my god, it's a lot of words. I think I can improve on this. The format of the responses that we have given right now is basically previous admin comments. There have been quite a few doubts asked at interview ready, and we have converted the previous admin comments into vectors, and even the queries uh, into I'm sorry, we have not converted them into vectors. We have actually used that as a one shot or three shot example. So we take those examples and we feed that to the model. The model comes up with a better response then. This is happening all during inference time. Okay. So it came up with a response in 10 seconds. Yes, I'll have to read this, but this is much better than Gaurav coming back with a response in 24 hours. So that's the major benefit. And let's say you are on a weekend and you have a query and you answer the query, and Gaurav is also on a weekend. So that's going to be a 1 day or a 2 day wait. So it's not worth it, because when you come back, it's going to be in the next weekend, which is 7 days away. So it completely destroys the flow. Instead, this is much easier. So yes, coming back to what we are trying to do now, we are trying to look at how did the quality, the accuracy of this model get increased to an acceptable level, to a human level. Yes, MRAM has come up with the response of documents which are related to the course. In general, documents which are related to these queries can be sent to the model for context. Okay. Some of us are coming up with a thought of we can use a graph DB. The graph DB can point to relevant sources. We can manually maybe set this up. How can these documents be found quickly and without setting things up manually in a graph? How would you set up your system so that it finds documents related to the query quickly? If I come up with the query of what is a SLM, is it A or AND? But what is a SLM? How does it find those video transcripts which are related to this query in our system quickly, and then sends them to the model so that the model can use this transcript to respond to the user? Any thoughts, guys? We have done this previously in the previous 5 sessions. We first went through attention, then we went through vectorization, then we went through I think the third one was masked attention. Okay, the first thing that we need to have is some sort of a store, either a file store or a database that is going to be storing all relevant objects for our query. So in our case, those are transcripts. But it could also be something else. So in a system like Google, you want to know what is the user interested in, then you go through the search queries, and you also go through the things that they have clicked on. Okay, so that might be in a data store. But finding the relevant things is complex. Like given a query, finding things relevant to that user quickly is difficult. So what is that tool that we use to do this for us? It's vector databases. Okay, these databases can store objects as vectors, with the main benefit being that when you store them like that, you're able to find relevant documents quickly for an incoming query. The idea of, if I ask you what is an SLM, what's a small language model, you're going to go through all the documents in your system, and you could have done a single parse. You could have gone through every single word and found out that, okay, small language model appears in this document, small language model appears in some other document. That would have taken a long time. But if you can convert the entire document into a single point in an n-dimensional space, in a 2D space, let's say, and you have an incoming query here, and you have various documents spread across your system. If you're looking for the top 3 documents, what you're going to do is you're going to start looking at the distance from your incoming query, this blue thing. So this is the input, blue vector is over here, and the remaining documents which are in red are like points in this n-dimensional space. You're going to find the 3 nearest ones. Can someone tell me what would be a search indexing technique to do this quickly? How do you find vectors quickly in such a vector database? This could be useful in real life also. Yeah, I mean, this nearly every practical application that you'll create will be using this. You as an engineer will come in at this point and say that, okay, how do we index our vector database? Here are some techniques. What would we use? Would you use B plus trees? No, they don't exist for vector DBs. What could you use? I'm sorry guys, is there some lag? Excuse me. Cosine similarity would be good. It would help you define how close a document is to the incoming query. But I'm thinking about reducing the search space. So if you have hundreds of thousands of points like this, not necessarily documents, but pieces of information which are relevant to an incoming query, then how do you go through them? Instead of storing the entire document, maybe you want to store 4 paragraphs. Typically it will be like 10 or more. So if you have 1,000 documents, you will have now 10,000 paragraphs to go through. And in real time, you will have to find, for an incoming query, which paragraphs are relevant and pass them on as context to the large language model. How do you do this efficiently? What can you do to quickly return the paragraphs which are relevant to an incoming query. Graph DB, okay. I think a lot of us are fascinated by graph. Um, and it is an interesting approach because I guess visually you can see things, or it feels like these things are connected, but there's something else. Chunking, okay, that's an interesting idea. But how does chunking help you find the relevant paragraphs quickly for an incoming query? In a database, if you have to find records which are related to an incoming record, how do you do that? Like, how do you do that quickly? So, is there any particular technique which helps you search a database quickly? Ashwin has mentioned B tree. So, what is a B tree? It's a it's a data structure which helps you index a relational database. What would you use here to index your vector database? Ta-da! Ta-da-ta-da. We have 2, 3 big eggs. Fill the eggs with text. Tell me what you're thinking. Vector similarity search. Yes, MRAM. So the particular techniques that we are talking about, the most popular one right now in the market is hierarchical, navigable, small worlds. This is very popular for vector search. And there are other techniques like inverted, I think it's vector file, but I have to confirm that. But IVF, yeah, it's got so many meanings here. But both of these are very popular to search for vectors in a database. These are indexing techniques. So let me just refer to interview ready's indexing techniques here. Inverted file index, yeah. Oh, so it's IVI, right? Or IFI. Why would we call it IVF? I have no idea. I think I hallucinated myself. So it's inverted file index. So IFI is probably, there's some stuff going on in my head maybe. So inverted file index. This is perfect. Mansoor is also saying that you can do a full text search. That is possible, but it's not very fast. So a full text search is going to take your time, and also the quality of the responses in a full text search are not up to the mark as compared to a vector search. Vectors are able to encapsulate information very effectively, and full text search, you're either doing a substring matching or you're doing some sort of fuzzy logic, which is again got to do with substrings and subsequences, information density. They are very handcrafted processes. This is more automated and also scales better. Okay, so once we have these two, once we have basically a way of indexing vectors in our database, we can then make sure that the relevant paragraphs are picked up by the database and sent to the large language model. The large language model looks at this stuff, relevant paragraphs, looks at the user's incoming query, looks at some of the system context that you have given, that I am a teacher, and I'm talking to working professionals, I'm talking about system design, I'm talking about AI engineering. When you give that system context, when you give the user's exact query, and even the user's query can be augmented by, this user has been asking questions around databases earlier, so maybe they want to know more about databases right now also. So you give them that. You give a format that please respond in such and such way. Earlier administrators have responded in this way. These are some previous admin comments, so examples. This is called few shot prompting. And then you have finally, here's some relevant context which is picked up from the website or picked up from our database. Please use all these sources of information to come up with the best possible response. And so that's 1, 2, 3, 4. The LLM has a much better chance of coming up with highly accurate and relevant, meaningful responses. Okay, that's the whole process of RAG. That's what we were also looking at in Interview Ready. When I started asking it questions, it started coming up with reasonable responses. HNSW is slower than IVF as I need to work on it layer by layer. So, is it slower? No, it's not. Is slower primarily due to its layer by layer search mechanisms? I don't really think it's true. Just creating this and managing this in memory is a problem sometimes. This is more of a software engineering thing. This can be pretty heavy to store and create. The complexity, complexity can introduce additional overhead. Okay, so I would say that if you're doing a time complexity analysis, you'll see no difference. HNSW is log n if you have n vectors, and I VF again. I'm sorry, I have done this. IFI should be probably what I do. Inverted file. Oh, they call it IVF. I think the creators of this have something in their head, and they've passed it on to me. Now, actual performance depends on the specific use case and data characteristics. Okay, it is slower, but this is more intuitive. This is easily understandable. IVF is also quite easy actually. So you can check them out both here in this lesson, vector search. Okay, and this is something which you can download. All right, so at a high level, folks, we'll stop here because I think this is probably the maximum we can take, the first 15 minutes of a session on Saturday. But at a high level, what we have learned is if we are trying to build an application, a few things that we should consider is cost, scale, quality, and setting the right boundaries, making things relevant and meaningful. The first two things that we talked about were cost and scalability. Here we had some ideas, which was quantization, using smaller language models, maybe distilling those models. So yeah, this is something that we mentioned. Using smaller models, using smaller weights, and reducing the amount of token usage. So information density, increasing that. Then we had quality discussion. We went for specificity first, where we said that if you give the model a particular format, it comes up with a good specific response. It explains things in the way that you ask it to, if you give examples. And also, its reasoning is easier because it goes through things step by step and usually comes up with a sensible final output. Finally, we talked about accuracy. Here we had some ideas around graphs, but what you really want to do is you want to have your relevant objects stored in a vector store and retrieved quickly during runtime, during query time. And the way that they're retrieved is by creating indexes on these vector stores Two of the most popular indexing techniques are hierarchical navigable small world and inverted file. Okay, once you go through this stuff, once you go through these steps, you can expect that your application is going to have good quality and can replace most human queries. Even then, there needs to be a way to escalate to a human, but yes, this is how it is. Okay, any questions, guys, in the last minute? Otherwise, we'll call it a day. And thank you so much for making this possible. In fact, this series has been very interesting to me. I think this last session has been very easy for many of you because you have gone through the first 5 sessions. So, and in case you have not, that's fine. There are recordings which are available on YouTube. Future sessions will be happening at Interview Ready, where we will have live classes twice a month. And the first one that we are taking is applications. We are going to go deep into this. Then we'll be taking MCP clients and servers. Then we'll be looking at agentic AI. And so the classes will continue around AI engineering. Okay. This is part of the Interview Ready, basically the platform. If you purchase the system design course or the AI course, it will be added to your profile. You can see it in the Zoom classes here. Okay, on your Zoom tab, you'll be able to see this. Also on live classes, of course, you can see it. So you can see event details. You can integrate your Google Calendar. In that way, you don't miss any class. Okay, these are all included to all Interview Ready users. Yeah, so that is what is up, and currently we are running I would say a long campaign. Basically, the price right now for the AI course is at the lowest that it is going to be because it's a new course and content is still being added as we speak. Here you can see that we have vectors. So there's a lot of detail in which we have explained what vectors do, how are they searched, how are they compressed, how are they stored, and how is indexing done on them. Okay, after that, what is a large language model, the practical side of engineering, just an introduction, how they work, what's generation, how do you improve things, RAG, and then we go deeper into these models. So we start talking about attention, transform architecture, KV caching, and after this things get even more complex. At this point, I think if you just go through this stuff, you'll have a decent idea of what large language models are and how they work internally. But then you should also, I mean, if you are looking at these models, it's good to know some of the optimizations that you can do. Okay, all of these are core optimizations, so they are usually done by the models themselves. It's not an engineer who does this, but there are also trade-offs which an engineer can choose from. So, do you want a quantized model? Do you want a full model? Do you want speculative decoding is something that you want to incorporate in your model? Sparse attention is another technique, and distillation. Distillation is different from quantization. As you'll see, distillation is reducing the number of parameters in the model. Quantization is reducing the size of the parameters themselves. Okay, and the next lesson that's going to be coming is reasoning in large language models. What I'll do is I'll take this and open it in the incognito tab because I don't get to see the launch dates, but you do. Releases on 28th June this month. Reasoning models, chain of thought, and reinforcement learning with human feedback, RLHF. You then have a transformers deep dive where we go into how do these models work, a second pass. The reason for this is because the first pass we have just gone through the intuition. The second pass we'll go through the more math involved stuff. MCP agents and practical applications is coming out on 12th of July with the coding assignments. So I'm looking forward to you joining this. Even at this point, the AI course is very, very useful if you're looking to start with AI engineering, because if you go through this stuff, you already know how LLMs work internally. As an AI engineer, you already understand it. Reasoning and transformers deep dive are coming soon. So grab the course while you can, and If not later also, it's not going to be very expensive, but this is the best price that you'll get. Okay. Thank you everyone for coming. Thank you for making this possible. Do let me know if you have any doubts or suggestions in the comments, and I'll see you next time. Have a great day. Bye bye.